Hey, Mike from Prep Pros here, and we're going to go over 10 things that you're going to see on your August SAT. We're going to cover one really important change to the SAT that was just snuck in over the past 2 weeks from College Board, and we're mostly going to focus also on the second harder math module where most students are hitting a brick wall on test day. At the end of the video, I'm going to talk about some of the resources that I've been using with my students to help them get those perfect or near perfect scores on the math section. We're also going to cover a little bit of reading and a little bit of grammar as we work through the video. Now, the first thing that I predict you're going to see are some exceptionally difficult exponential growth and decay questions. We're actually going to take a look at one that the College Board's just snuck into an update of their first 3 practice tests. So here we see for the function f, for each increase in the value of x by c, where c is a positive constant, the value of f of x increases by a factor of 27. This means it's 27 times greater. Which of the following equivalent forms the function f displays 1 over c as a coefficient of x? Now, when most students read through this, at the end they're like, I have no idea what I'm looking for because how am I supposed to possibly know what c is? Now, anytime you deal with these types of questions, they're going to sneak in some information which is going to let you solve for it. Now, what we know is these are all equivalent forms of the function f. In using our basic understanding of exponential growth and decay, we know all of these equations are going to have the point 0, 48 on them. This is always our starting value that comes before the parentheses. And now we have to unpack this first sentence to be able to solve for c. For each increase in the value of x by c, so every time x increases by c, the value of f of x or y increases by a factor of 27, so it means it's 27 times greater. So this means we're also going to have the point c, 48 times 27, which is going to give us 1,296. So this is now going to let us solve through. We can use any of these answer choices because they're all equivalent forms of the function. So I'm just going to use A because it looks easiest for me to use. So what I'm going to do is I'm going to plug in 12,096 for f of x or y, and we're going to use that to solve for c. So this is going to be equal to 48 times 3 to the 1/2 c. Now if we want to solve for this exponential piece, we want to see if we can create the same basis. So we're going to divide this entire expression by 48. This is going to leave us with 27 equals 3 to the 1/2 c. Now 27 is the same as 3 to the 3rd power, so we can rewrite this as 3 to the 3rd equals 3 to the 1/2 c. We can cancel out our bases, therefore we know that 3 is equal to 1/2 c, and that's going to tell us that c is equal to 6. Now we get to the final part, which of the following equivalent forms of the function f displays 1 over c, or 1 over 6 is a coefficient of x. Well, here we can see that b gives us 1 over 6x, and that's how we can find our right answer. Now, the next thing that you're absolutely going to see on your test is a discriminant question in some form. There's quite a few varieties of these that can show up on the test, and I know a lot of students got one as the last question on their June 2024 digital SAT. So here we see the given equation ax squared plus 78x plus c equals 0, where a and c are constants, has no real solutions, and a factor of gx plus p. The product of ac is greater than k. What is the least possible value of k? Now, don't worry about this factor part. This is just the SAT throwing in more information to overwhelm you. But what we want to do and look out for on tests so you can spot these is as soon as you see a quadratic and you see the question talking about the number or type of solutions, that tells you it's a discriminant question. And here, since we have no real solutions, that means we're looking at b squared minus 4ac is less than 0. Our a value is a, our b value is 78, and our c value is c. So we can just set this up as 78 squared minus 4ac is less than 0. Now this is going to give us 6,084 minus 4ac is less than 0. So we're looking for the product of ac is greater than k, so we can add over the 4ac. We're going to get 6,084 is less than 4ac. Well, if we want to figure out what ac has to be greater than, we can just divide this entire expression by 4. And as we do that, we will get that 1,521 is less than AC. Now, as we come back to this, they've added this kind of final wrinkle to just confuse students a little bit. We're told the product of AC is greater than K. What is the least possible value of K? Well, we're told that AC has to be greater than 1,521. So this just tells us that our least possible value of K here is going to be 1,521. That's our final answer. Now, the next thing you're definitely going to see on your SAT are the SAT's favorite trig identities. And these are that sine of x equals cosine of 90 minus x, and cosine of x equals sine of 90 minus x. So I've popped this figure in from my book, which is hopefully going to help this concept click a little bit quicker for you. But what this is really telling us is two very important things. One, the sine of one acute angle x in a right triangle is equal to the cosine of the other acute angle, 90 minus x, or the same statement flipped for the cosine is equal to the sine. But the other super important piece this tells us is if the sine of one thing is equal to the cosine of another, that means that they are complementary. It means they add up to 90 degrees. So for very sneaky, tricky questions like this, where it says for two acute angles, angle A and angle B, cosine of A equals sine of B, what the SAT is sneakily telling you here is that angle measures A and B add up to 90 degrees. Now, if we can pull that statement out, we can take this really challenging question, we can make it quite easy for us. What that tells us is if the measures in degrees of A and B are 13x plus 10 and 48 plus 3x respectively, well, this just tells us that these two things together have to add up to 90 degrees. Now from here, this is a pretty easy question, but these can show up as some of the last questions of your first module or those kind of death row of questions about the last 5 or 6 in the second module. But this now is as simple as just doing 16x plus 58 is equal to 90. And this will give us that 16x is equal to 32 degrees. Therefore, x is equal to 2, and that will give us our final answer. But make sure you memorize this. Look through this figure down here, which will hopefully help this click as well. If you have any questions, drop them in the comments. Now, the next thing you're going to see on your test are what I like to call tricky transition questions. And you're going to be able to spot these quite easily. If they show up, you're going to see comma transition semicolon or period or colon or single dash. You're going to see the opposite. Here we see semicolon transition comma. You're going to typically also get one option with 2 commas. And now you have to figure out which one of these is correct. And why these are such tricky questions is they involve a few skills here. Now, the first thing is we need to understand our clauses and how to connect them. If this is something you aren't familiar with, independent, dependent phrases, I strongly recommend checking out my free trial. It's going to learn all those foundational elements, but we're going to move ahead like you're comfortable with that because it's going to be really easy for you to pick up in there, and then this can help you find the right answer to this. Now, when you see these tricky transitions, the first thing I simply want you to check for is what is coming before and after the transition. So essentially, mentally, cover up these transitions to start with and look what's coming before and after. And we can look directly at the sentence before and after. Okanaka doesn't make such decisions single-handedly. This is going to give us an independent clause. Now we're going to ignore that, however, to start with, and we're going to look at what's coming after. All historical designations must be approved by a group of 9 other experts from the fields of architecture, archaeology, history, and Hawaiian culture. Well, we have another independent clause. Now, if you see independent before and after, this is automatically going to lock you into an answer choice, which is going to give you a proper way of joining those 2 independent clauses together. And that's why understanding these rules is so important. Now, if you do not have independent before and after, this is going to pretty much automatically lock you into the answer choice with the 2 commas. So we've already knocked out 50% of the answer choices. Now, the really tricky part is how are we supposed to tell if we should use comma, transition, semicolon, or semicolon, transition, comma? And this now becomes a context understanding. If you're using this, you're signaling the transition is working back to the left, which also essentially means you should be able to pop the transition at the front of that sentence. Versus this is saying the transition is showing the relationship between this second sentence and this third sentence. So we want to think where the contrast is happening. I always recommend to start out with this structure first. So that means we're going to simply pop the however right in here. We're going to read first, second to sentence and see if that makes sense. Sociologist Alton Okanaka sits on the review board tasked with adding new sites to the Hawaii Register of Historic Places, which includes Pilanale, Heiau, and Obekaka Bridge. However, Okanaka doesn't make such decisions single-handedly. That makes sense. We're saying this person is sitting on the review board, they're involved in these decisions, but they don't get to make the decisions alone. We're showing us here a clear contrast there. That's why A is correct. This second answer choice of B does not make sense because we're not seeing a contrast between this second sentence and this third sentence. If we say Okanaka doesn't make such decisions single-handedly, However, all historical designations must be approved by a group of 9 other experts from the fields of architecture, archaeology, history, and Hawaiian culture. These two ideas are in agreement. He's not making the decisions alone, and then we're talking about how they have to be approved by other people. If this was changed from like a however to a furthermore or an additionally or an accordingly, we would have to use this type of structure. But since we have a contrast between sentence 1 and sentence 2, that tells us that A is correct. Now, the next thing you're going to see on your SAT are advanced exponent questions, and this is one of the common varieties. The other ones I have in my advanced math course as well. Here we can see two numbers A and B are each greater than 0, and the square root of A is equal to the cube root of B. For what value of x is a to the 3x minus 4 equal to b? Well, the first thing we want to understand is we're saying the square root of a is equal to the cube root of b. I always like to use my fractional powers with these because they're far easier to work through. The square root is the same as the 1/2 power. So we can say a to the 1/2 equals b to the 1/3. The cube root is the same as the 1/3 power. What we're solving for is we know that in the final sentence they tell us a to the 3x minus 4 is equal to b. And we want to solve for x. Now, if we ever want to solve for a variable in an exponent, we need to be able to have our bases the same so we can cancel them out. So what we need to do is we need to use this second equation so we can substitute in another a value for b. That basically just tells me I want to make this second equation here that we're now looking at, I want to make this equal to b. And the easiest way I can do this is I can just simply raise this entire expression to the 3rd power, because 1/3 times 3 is going to give us 1, and now we can substitute in. So we can rewrite this as a to the 3/2, 1/2 times 3 is equal to b. Now we can substitute this in. So now we can say a to the 3x minus 4 is equal to a to the 3/2. Now we can cancel out our bases, and now we know that 3x minus 4 is equal to 3 over 2. So I'm going to add over my 4, which is the same as 8/2. So this will give us that 3x equals 11 over 2. Now we can divide both sides by 3. And this is going to give us that x equals 11 over 6. And that will be our correct answer there. Now, the next thing that you're going to see on your test is a really important update to notes questions that College Board snuck in the last week and a half when they updated the first 3 practice tests. Now, this only appears once in all 6 Blue Book practice tests, but I anticipate this is their way of signaling that you're about to see this change appear on your August test. And this is that no longer are all of these questions answerable by simply finding the one answer choice that actually appropriately answers the question. They now have put 2 answer choices that appropriately answer the question, but only one of them is accurate given the notes. So this now means we have to be very careful with the accuracy of what we're picking. We can't quite shortcut these questions as aggressively anymore. We still want to make sure we're answering the question, explain how pineapple extract increased the growth rate of P. javanicus, but here we can see both B and D do explain how it increased the growth rate. But now our very tricky part here is now we're dealing with accuracy. In turn, affecting the fish's total food consumption did not affect total food consumption. So that's how we can see that D is our correct answer. Just be on the lookout for these questions of being very careful with what you're picking is accurate given the notes in August. Now, the next thing that you're definitely going to see on your SAT, they show up on every single SAT, are support or weaken the claims questions. Now, these are going to be really easy to spot because they're going to kind of hit you over the head that that's your job. Which finding about the basin, if true, would most directly support Cardenas and Lamb's conclusion. But we're going to talk about a general understanding for these questions to hopefully help you pick some more of these up. Now, the general approach that I recommend for most students is simply read through the passage your first time for general understanding, find the conclusion, and then this essentially should function as your filter to help you figure out what pieces of evidence in the passage are going to let you know what is truly supporting or weakening the claim. So I'm going to recommend pause the video here, read through, see if you can find the right answer. Now, once we see that the conclusion says that the wet and warm scenario is likely correct, our job simply is to go back through the rest of the passage and find any connections related to the wet and warm scenario. Everything on the SAT is right for 2 simple reasons. It's answering the question and it can be justified by information in the text. So here we see Looking back at our first sentence, although it's clear that Mars once had liquid water on its surface, astronomers have debated whether the evidence of ancient water reflects a prolonged phase of warm-wet conditions, the so-called wet and warm scenario, or a brief period of melting in an otherwise consistently frozen environment. That's all we get here. This isn't as complicated as some of these can get, but what we do want to start to understand is all the language they tell relating to this claim is incredibly important. They say reflects a prolonged phase of warm-wet conditions. That's the only information they give us to tell whether the warm-wet scenario is actually likely. They say it has to be prolonged. And that's why B is our correct answer. We see it has features suggesting that it once held an ocean that underwent gradual sea level changes over an extended time. This is connecting back to prolonged phase. Your most important principle is understanding you have to have evidence you have to connect back to. If you feel like none of the answer choices are making sense, it means you may have missed a single keyword like we have here, or relationships established in the passage, which are going to tell you which answer choice has to be correct. Now, the next thing you're definitely going to see on your SAT, whether it is in this super difficult version that we're looking at here or a little bit of a simpler variation, is going to be a scale factor question. Now, this table from my book is really important to memorize because if you have this down, you can really work through these questions far more easily than you think possible. So our scale factor rules are really telling us the relationship between the scale factor, which is going to be the multiple of the side lengths of our similar shapes, to our perimeter, which if we'll just use 2 here, if our scale factor is 2, if our side lengths are 2 times as long, our perimeter is going to be 2 times as long of the bigger shape than the smaller shape. Now, area and surface area are in squared units, so this gives you a really easy way of remembering your scale factor relationships. If your side lengths are 2 times as long, your area multiple is going to be 4 times as great. It's going to be that scale factor squared. And with volume, since it's in cubic units, it's going to be your scale factor cubed. So if our side lengths are 2 times as long, the volume of the larger shape is going to be 8 times larger. So when we look back here, the table gives the volumes and surface areas of 2 similar rectangles where k is a constant. What is the value of k? So this is from my advanced math course, so this is the super hard variety that has been showing up at this end of the second module for some students. But we can still use these same basic scale factor rules. If we take our 1,500,282 and we divide it by our 4,374, this is going to give us our volume multiple. And in this case, it's going to give us 343. Now what we know is our volume multiple is equal to our scale factor cubed. So if we want to figure out our scale factor from here, we can take the cube root of this, and that's going to give us 7. So we now know that 7 is our scale factor. Well, what we know is our surface area or area multiples of one shape to the other is going to be our scale factor squared. So once we know that our scale factor is 7, we can simply do 7 squared times 1,782, and this is going to give us our correct answer here of C. If you want more practice with really challenging questions like this, strongly recommend checking out my advanced math course. It's worked wonders for quite a few students over the spring, and I know it can do the same for you in August. Now, one other thing that you will see on your test are questions that can be solved very easily in Desmos compared to doing it by hand. If you're familiar with some of the more advanced Desmos capabilities, especially the regression tool. This can be applied for exponential equations, quadratic equations, but we're going to start with the most basic level here, which is a linear equation. So here we're told the point with coordinates a, 6 lies on the line that contains the points 0, 8, and 7, 0. What is the value of a? Well, I'd like Desmos to graph this line for me, and I know 2 points. So we're going to type in table, and then we're going to put in that 0 and that 8, and that 7 and that 0. Now, we want a y equals mx plus b equation, but we need to tell Desmos that we want it to perform a regression, so it's going to use these values from the table to solve for that equation. So we're going to type in y1. Remember, you have to type in y1 so it pulls from that y1 value. Then you'll hit this tilde, and you'll do mx1 plus b, and it's going to graph the line for you. Now the last step here is kind of learning how we can coax out the points in the most efficient way. We could absolutely slide along this and see what the x value is when y is 6, and eventually we'll find our answer, but the easier way we can do this is we know we have a, 6, so we're looking for what x is when y equals 6. So if we want to get a nice point of interest, we can just type y equals 6, and that will give us that a is 1.75. And the last thing that you can do here is if you type in that 1.75, you want to put it in fraction form, just click this little fraction button, and Desmos is going to do all the heavy lifting for you. Now, the last thing you're definitely going to see on your SAT are sentence structure questions. And these are the easiest grammar rules that you can learn, and they show up for a ton of those standard English convention questions. This is just how we can be joining independent and dependent clauses together properly. So here we see I'm going to skip pronouncing this, the museum in Uncasville, Connecticut was founded in 1931 with the goal of showcasing the cultural and history of the Mohegan tribe. Well, that's an independent clause. Today, nearly a century later, it is the oldest native owned and operated museum in the country. Also an independent clause. This is why these rules are so incredibly important, because only one answer choice is going to allow us to join those two independent clauses together. And that's our commas and fanboys, and that's how we 100% can tell that A is correct and not try to rely on our ear or what sounds or feels right. So if you want to learn these rules, check out the free Trial to My Ultimate SAT course. You're going to get all the in-depth lessons on how you can spot these, the common pitfalls, a lot of practice with these. You don't need a credit card or anything, but it's a really easy place that you can easily improve your reading and writing score, just 30 to 40 points, just starting to understand these rules. Now, I really hope this video has helped you out so far, and now we're going to talk about some recommendations I have to help you improve your SAT score as much as possible heading into August. Now, August is always a little bit of a unique SAT because some students are in school and some students are still out of school. If you are out of school, you can make some pretty enormous strides in a week, week and a half, 2 weeks if you're willing to put in the time. Now, as I talked about at the front of the video, I was going to mention the resources that I've been using to really help students score in that 750 to 800 range on SAT math. And what I would recommend for you is working through my advanced math course. It's really just focused on those last 4 or 5 questions that you're going to see in the harder second module, and it's going to make everything else feel a lot easier for you. Now, if you are watching this video last minute and you haven't done a good job of preparing over the summer and making the best use of your time, and you're just looking for the easiest places that you can improve your score, I strongly recommend checking out my SAT crash course. It's basically perfectly designed for you. We're just going to cover all of the places that we can move your score as quickly as possible, teach you a lot of rules, content, strategies, tips, and tricks. So I definitely recommend that. Now, if you're watching this and you have a week, week and a half, 2 weeks left, you're not in school and you're really trying to make some enormous strides across the entire test, I'd recommend checking out my full Ultimate SAT course. You can make some serious improvements once we learn the rules, strategies, tips, and techniques. Now, the bare minimum, all of you should check out the free trial to my SAT course. No credit cards are needed, and you're going to learn a lot of those fundamental and foundational rules that we talked about earlier in the video.